Hello again and welcome to a new lecture on mechanics in which we will study about a new concept, the section modulus, which is very helpful in designing certain types of sections for beams. So let's recap a concept and remember that we have in general two types of sections. Let's call the first group custom sections, and this group will include all kind of square, rectangular, circular, triangular cross sections, which are called custom because we will, if needed, we can order them at various dimensions that we need. And for these sections, based on their dimensions, we can easily calculate the second of moment of area or the moment of inertia, as well as the maximum distance from the centroid to one of the extreme fibers of the section, and then apply the bending formula as such and determine, for example, the properties or the size of the section based on calculating the ratio between I and Y max. And then we can determine the section that we need. The other group of sections are the so-called rolled sections, which are sections normally manufactured through a process called rolling. And we discussed about that when we talked about trusses before. These sections could be angles, again, we've learned about angles before, or we could have other types of sections like wide flange sections, hollow structural sections, channels, and many others really. Now, the important thing about these rolled sections is that all of their section properties are tabulated. They're already included in tables. So somebody else has gone through this effort and calculated all properties, and you do not need to calculate them. And also, if you do so, you will probably get wrong values because these shapes are very complex with round edges that are very difficult to include in manual calculations. Therefore, we defined a new parameter called section modulus, which is a constant equal to the moment of inertia divided by the distance from the centroid to the maximum top or bottom fiber. So section modulus is denoted by letter S, and again it is a parameter that is tabulated for these sections. We can pick this parameter, look it up in specific tables, like for example this one, which is for hollow structural sections. You can see in the top right corner how a rectangular hollow structural section looks like. So it's like a rectangular section but with a big rectangular hole in the middle, and all the properties for such a sections are tabulated, as you can see in the excerpt of the table below. But what we're mostly interested in now for beam design is the section modulus, and there are two values, each corresponding to either the x or the y axis of bending. Now, for example, if we select a section that is designated as HSS 305 by 305 by 305 by 203 by 9.5 millimeters, then this is the section dimensions, and 9.5 is the wall thickness. We can look up the values for the section modulus, which is 762 times 10 to the power of 3 millimeters to the third for bending about the x-axis, and 611 times 10 to the power of 3 millimeters to the 3 for bending about the y-axis. So as you can see, it is very important to know to identify the axis of bending, and therefore use the correct value for the section modulus. Again, the axis of bending is the axis that is perpendicular to that direction of the forces that act on the beam. Or in other words, is the axis along which the bending moment vector acts. So thank you very much for attending this lecture, and I will see you at next ones where we will continue with the design of beams.